My name is Neil Kloper, and in this video, I'm going to explain the process I used for my submission to the ODSC Data Science Hackathon, my findings in the dataset, and some key takeaways I have from the experience. The dataset used in this competition is the electric motor dataset from Paderborn University. The data is already scaled based on its z-score, so there isn't a great deal of variation in scale or distribution of the features inside this dataset. The notebook titled ODSC sklearn has my exploration of the data, attempts at feature engineering, and initial baseline. I began by overviewing a basic pair plot and then diving deeper by creating a new dataset where the target variables were changed into binary values which represented which side of the value's mean it fell. While there were some clusters that were easily distinguishable, the majority of the data points were not linearly separable from any value. I chose to use models that made inference based on individual rows instead of seeing each row as an element in a time series, which did hinder my performance. When splitting the data for training and validation, I discovered that doing a random split created models that overfit the training and validation data, which is a common problem in time series. Splitting by index location created models that had a closer validation and test score. Later, when I was running tests with neural networks, I was able to use random splits and still maintain a reasonable delta between the validation score and the test score. As one last test of the notebook, I created a function to calculate the permeation importance, and I discovered that the majority of the signal was coming from only three features: the ambient temperature, the coolant temperature, and the D component current. How permeation importance works is by testing a model on the same dataset multiple times. Each time, the model is retrained on the dataset with one feature randomized. As it iterates through, it's able to see how much randomizing a single feature negatively impacts the accuracy of the model. So it's ultimately able to determine whether or not a feature is adding signal or if it is contributing noise. Fast AI Notebook sets up neural nets for tabular data. This notebook isn't necessarily meant to be run in order. As you will notice by the commented out code blocks, I used a variety of methods to train the models contained in these notebooks. In some cases, validation set of the data was selected at random. Other times, the validation section was selected by splitting the data based on a point in time, typically the final 20% of the data. I trained many different models with different architectures so I could see what capacity the model would need in order to be able to match the complexity of the problem. Of the target features, PM, or permanent magnet temperature, had the greatest complexity to it. Initial two-layer models were very ineffective at estimating this feature. Once I started using models with 5 or more layers, the performance greatly improved. The goal of this notebook is to create a blend of models which, when they have their predictions averaged, produce a decent score. Blended results had a root mean squared error score of 0.47, where the best individual model in that blend was able to achieve a score of 0.45. However, the mean absolute error of the blend, or average distance of the prediction from the actual value, went from a score of 0.35 for individual models down to a score of 0.21. To put that into perspective, if a model only guessed the mean value for every entry, it would have a score of 0.91 for root mean squared error, and for mean absolute error, it would have a score of 0.83. There is room for improvement. I think semi-supervised learning would have been able to achieve some higher performing results. I also know that I was unable to get alternate loss functions to work properly on the tabular learner, which could have helped me get a more diverse blend of models. I also could have improved things further by doing data augmentation. I did enjoy this competition, and while I didn't score as high as I would have liked to, I did learn a lot in the process. It has helped me to get a clearer idea of where I want to be focusing my studies next on my machine learning journey. Thank you for viewing my submission,